Hi everybody, my name is Steve Earth, and I'm one of the students in edX's Effective Thinking Through Mathematics class with instructor Professor Michael Starbird. And in the very first week he presented a problem which he called the Pirates and the Admirals puzzle, and I thought I would go ahead and share my solution with you for that. So here's what the problem says. It says, 3 pirates and 3 admirals walking together approach a river. The river is too wide to swim across, and there is no bridge in sight, but there is a single rowboat on the bank. The boat is only big enough to fit 2 people at a time, and since it's not a magical boat, it requires at least 1 person to row it across the river. Now, the pirates, being as they are pirates, will attack the admirals if they ever outnumber them, but if there are more admirals than pirates on a side, or an equal number, everyone will remain friendly. So can you help everyone get across the river without anyone being attacked? So, I have an approach which I haven't seen any of the other students use yet, which is to utilize a graph. But before I show you the graph, thought I would point out a misunderstanding of the problem that I had when I first read it. And I think it was just me, because I also showed it to someone else, and they also had the same misinterpretation. So here is my nice pretty graph. This represents the river, here's the rowboat, the 3 pirates, the 3 admirals. So the point of ambiguity happens is that the boat itself doesn't count as a separate region in terms of figuring out whether the pirates outnumber the admirals. So let me give you a quick little example. In fact, this particular example is going to be important later on when I show my graph. So let's just say for a minute that we're proceeding along the puzzle, we're doing some stuff, and at some point we end up on the original side of the bank. Maybe we've got 2 pirates and the admiral there, so that maybe at some point this pirate over here ended up being on the other side, like so. Alright, so let me show you what it is not legal to do. So what you can't do is say, hey, let's put a... So right now I should point out this is a perfectly legal state, right? The admirals outnumber the pirates over here, and here the pirate has no admirals to beat up or anything. There's no admirals on this side. So let's just say that you decide to load into the boat 1 pirate and 1 admiral. So let me just go ahead and do that really fast. So here the pirate and the admiral jump into the rowboat, and notice this part of the bank is going to be fine because the admirals outnumber the pirates. Over here, again, this part's going to be fine. So what it's tempting to do is say, okay, the boat's going to travel over here, and what's going to happen is that the admiral's going to sort of stay in the boat and row it back. So it would look something like this. So here the rowboat with the pirate and the admiral have now traveled to the other side of the bank, and it's tempting to say, okay, well they're in the boat, so the admiral's safe, and now at this point the pirate just needs to get out of the boat, like so, and then the admiral here could just sail this boat back and be okay. But it turns out this is not a legal thing to do, because as soon as the boat sails over here, this is considered to be all in the same bank, and the fact that the admiral's in the boat is actually not really relevant. The 2 pirates are going to jump the admiral, and so it's an illegal state, because now they're going to be attacked. So it's not a legal thing to do. So if you ever have 1 pirate over here, you cannot sail over with a pirate and an admiral. Alright, so I'm just resetting the puzzle here back to the initial state with the 3 pirates and 3 admirals and the rowboat on this bank, and what we want to do is get everyone over to the other side. So the way I thought about this puzzle is, imagine that there's a camera here on this side of the beach, and it takes a picture of just this side, and it only takes it when the rowboat is on this side. So if the rowboat's over here, it doesn't take a picture of anything. When the rowboat returns, it snaps a picture of what's going on over here. So if you think about it, if you just know the state of this bank right here, that automatically tells you the state of this bank. Because if I tell you that, oh, there are 2 pirates and 2 admirals on this side, well, you know there's 1 pirate and 1 admiral on this side. So all we really need to do is keep track of what's going on this side of the beach. So what I did is I made the x-axis represent the number of pirates, and the y-axis represent the number of admirals. So let me go ahead and show you what this is going to look like. Alright, so here's the start of the graph that I was referring to. So each one of these points represents a potential state that the puzzle could be in. So, for example, if we were looking at this dot right here, this means that we have 3 pirates, because it's in the pirate column, and 2 admirals, because it's in that row right there for the 2 admirals, and we're on the original beach with the rowboat. That's what this is saying. So, now, it turns out some of these states would be illegal for the puzzle. So let's actually take a look and see if we can identify some states that are just always okay. So let's do that first. So first of all, it's always okay to have 3 admirals on the beach. So that's never going to be a problem. So I'm just going to kind of temporarily highlight these to say that those are okay. We can always have 3 admirals on the beach. It's never going to cause any problems. So, by the same token, we can always have 0 admirals on the beach. So, I'm going to highlight these to say those are always okay. So having 0 admirals on the beach, you might say, wait, isn't that a problem? No, it's not, because that means on the other side you've got all 3 admirals, so they're definitely not going to be outnumbered, and we don't have to worry on this side about admirals getting beaten up because there are no admirals. So it turns out also okay is on the beach, the original beach with the rowboat, to have an equal number of admirals and pirates. So that creates this sort of line right here of dots that are going to be okay. So again, this diagonal line represents, like this dot would be 1 admiral and 1 pirate on the original beach with the boat. This would be 2 admirals and 2 pirates on the original beach with the boat. These are all okay, because if you've got an equal number on one side, you also have an equal number on the other side. In fact, if you're ever wondering what's on the other side of the river that doesn't have the boat, you know, the new bank we're trying to get to, all you have to do is reflect across this line. Just pretend it's like a mirror. So, for example, if you have 0 pirates and 3 admirals, that means on the other side of the beach you would have 3 pirates and no admirals. So, okay. Well, it turns out, remember the rule that we never want on our original bank, in fact on any bank, for the pirates to outnumber the admirals. So right away we can rule out this dot, right? We never want this state to happen because this means there's 3 pirates and only 2 admirals. That's bad. So anything that's underneath this line right here, other than the 0 admirals, these 3 dots are just no good. So I'm just going to go ahead and circle them. So these are no good. Okay, so, well, you might ask, well, what about these dots? Okay, so it's a little bit less obvious, but it turns out these dots are also no good. You might say, well, what's wrong with this one, right? Because here you only have 1 pirate and 2 admirals, so this dot should be fine. Aha! But what would be going on the other side of the bank? Well, to get the other side of the bank, you'd reflect it around. You'd say, well, if we've got 1 pirate and 2 admirals on the original bank with the boat, that means on the other side we'd have 2 pirates and 1 admirals, and the pirates would be beating up the admirals. So it turns out, for the same reason that these were no good on the original bank, these spots, even though on the original bank are okay, on the new bank it's going to cause problems. So let's just go ahead and get rid of these 3 points as well. These are also no good on the other bank. Now, it turns out there's also 2 other points that it's not obvious are no good, but actually are no good. So, and that is the zeros, so these 2 corners, 0, 0 and 0, 3. We have to eliminate these. So initially we think it's okay, but if we give a little thought, we'll realize this point actually should not be a part of the graph that we're going to make. So why is this one no good? Well, remember what this represents. This point represents the original bank with the boat there. The picture only gets taken when the boat is there. So how could you ever have, you might think, but this is what we want. We want there to be 0 pirates and 0 admirals on the original bank. Well, it turns out this is actually impossible to get to. You could never have 0 admirals and 0 pirates and the boat there, right? Because how could the boat have gotten there, right? So remember, it's not a magical boat. Someone had to have rowed it there. So how could you have, the original person that rowed it there would have had to have been on that side of the beach, and there's no one there. So this one is actually impossible. So let's go ahead and get rid of that one. So again, it's not like it's a bad state, it's just we can't reach it from the initial setup of the puzzle. So another thing that theoretically is okay, but actually cannot be reached, is this one. Okay, so you cannot, on the original side of the bank, have 3 admirals and no pirates. Okay, and the boat there. So why can't that happen? I mean, it seems like, on the surface of it, it's not a problem, but actually it is. Because how could... So think about the turn before. So the turn before, what could it have looked like? So here's the pictorial representation of what we're talking about. So that dot in the upper left-hand corner right there, the 0,3, that means we're on the original beach with the boat with 3 admirals and no pirates. So it would have to look like this, the 3 pirates over here. So the question is, well, how did this boat get here? Well, whoever rowed it is now here on this side of the beach. So the person that rowed the boat was either 1 admiral or 2 admirals, and it doesn't actually matter because that means beforehand that was either the drivers of this boat were over on this side. So that means you either had 1 or 2 admirals on this side together with 3 pirates, which is bad. That couldn't have happened if we were doing a legitimate solution. So even though on the surface of it this looks like it's okay, it's impossible to actually get to this state from the initial position of our puzzle. So, based on that reasoning, this point can also be eliminated as well. So that point we don't need to worry about. So now you might say, well, what if there's something we hadn't thought of and maybe some of these are actually no good as well? But it turns out they actually are, in fact, all possible. And we'll actually see that momentarily as we keep on building the next section of the puzzle. So let me update the picture a little bit so it doesn't look quite so messy. Alright, so here's the same picture as before, but I eliminated all the bad states that we never want to go to, and I kind of hollowed out these two here because they're not really a bad state, it's just that we can't actually ever get to it there. So I just put the dots there to sort of remind us there, I hollowed them out. So here's these other states that are totally normal, and I kind of highlighted these 3 in red. Well, why did I highlight these 3 in red? Well, it turns out this is our goal. This is actually what we want to get to. Now you might think, but wait, don't we want to get to 0 admirals and 0 pirates? Shouldn't we try to get here? But remember, we actually can't get to this spot in the graph because the way I built this graph, it's based on the original bank with the boat there. So what you actually want to have at the end state, the last part of this game, is that you want to get to one of these 3 red dots. Right? Because what this represents, the way you would win this game, is get the boat to the original bank when you have 2 or less people there. Because if you have 2 or less people in the original bank, then you just pile them into the boat and sail them to the other side. We just can't see that dot representing the other side on this because this was all based on the original bank. So the idea is what we want to do is sort of start at this dot. So this is 3 pirates and 3 admirals on the original bank with the boat. And somehow get to one of these 3 dots. Because if we can get to one of these 3 dots, then the next step, which would be represented in this picture, would be just sail off to the sunset with the last 2 or 1 person. So that's what our goal is. Now what we haven't put on yet are the connections that say how do you go from one dot to the next. So that's the next step in our reasoning, is to figure out, all right, where do these lines go? Alright, so in order to be able to draw on the different connections between that graph, we have to make some observations here. So one observation is that for each cycle of sending out the boat and having it return, then either the boat left with either 1 or 2 people, and then it came back with either 1 or 2 people. Now let's not even worry about whether those people were admirals or pirates yet. Well, we're going to just take that out of the equation for a minute. So let's just look at what the net effect is on the original beach. So I have to look at the entire cycle of it leaving and coming back because our snapshots on our picture are just with the original bank with the boat there. So it has to go and come back. So, well, what effect is it going to have if you send out with 1 or 2 people, it comes back with 1 or 2 people? Well, really, the only possible case is that when you go from one state to another, there was a net change of either -1 person, which could have happened if you sent the boat out with 2 people and came back with 1, or maybe a net change of 0, maybe you sent it out with 1 and it came back with 1, or sent it out with 2 and it came back with 2, or you actually gained a person, either a pirate or an admiral, and that came from you sending it out the boat with 1 and it coming back with 2. So the key thing to take out of this is that whatever the net change is going from one point to another, the total number either changes by -1, 0, or +1. So let's look at how that effect is on the individual types of people. So by a type I mean either they're a pirate or they are a admiral. So let's make a little chart here, and we're actually going to look at the net effect difference of what happened to the number of admirals and pirates when the boat left and came back. So it could be that one of the types went up by 2 and the other went down by 2, or vice versa. Okay, so type 1 is either a pirate or admiral, and type 2 is the other one, either admiral or pirate. So I guess I really didn't even need the plus or minus here for this case. But so notice that when you put these together, +2 and -2, this would be a net change for the total number of people is 0. Okay, I'm not even saying this is possible for our puzzle, but I'm just saying theoretically it could be that the pirates went up by 2 and the admirals went down by 2. So that would be you sending out the boat with 2 pirates and it comes back with 2 admirals. So, all right, well, what's another possibility? It could be that one of the types went up by 2 and the other one down by 1. Or it could be one of the types went down by 2 and the other one up by 1. Could have also been that one went up and the other one went down. And then the last possibility is that one of the categories went either up or down by 1 and the other one stayed the same. Now, this one's like a little mysterious. It's like, how could this have happened? So the way this could have happened is maybe you sent out the boat with a pirate and an admiral, and then it came back with just a pirate. So if that's the case, then your number of admirals went down by 1, but your pirates actually stayed the same because the pirate went out and it came back again, right? So that would be a case of like the admirals going down by 1. You also could have had like the pirates go up by 1. So how could the pirates have gone up by 1? Well, maybe you had a situation where like a admiral and a pirate go out. Wait, hold on a second. I meant to say that 2 admirals go out and come back with an admiral and a pirate. So that admiral kind of replaced himself. I keep getting that wrong. So one admiral goes out, and then he comes back with an admiral and a pirate. There we go. So then the admiral just replaced himself, and you actually made a net gain of a pirate. So that would be an example of a +1 and a 0 for that. So, okay, well what this is going to represent is the different slopes that we can have on our graph for our line. Now, in case you're wondering where like all these crazy numbers came from, I just want you to note these are all the different ways of adding up to either -1 or +1 or 0, and still doing it with numbers that are less than 2. So it's important to note that you can never actually have 2 positives or 2 negatives together. It's impossible for like you to gain a pirate and an admiral, or gain 2 pirates and 2 admirals, or 2 pirates and 1 admiral with a cycle, right? Because at some point the boat had, at some point the boat has to come back to the original because the boat's there. So you could have gained an admiral and a pirate, so great, that's +1 +1, except that you had to send it out with something. It's going to cancel out one of the ones. So the best you can do is like a +1 and a 0. So you can never actually have 2 positives or 2 negatives. Also, none of these numbers can ever be more than 2, because the boat can only hold 2 people. Alright, so let's actually go back to our original graph right here. Well, not quite the original, but the bad state's removed. So, and I kind of pasted in the little table that we have right here so we can put in our connections for how to go from one state to another, because it's not possible with the boat to go from this state like directly to this one, right? So let's look and see which ones are possible. So here, this basically says going like 2 down and 2 across. So, but if you look at this picture, there's no way from any dot that we can go 2 across and 2 down or anything like that and go from, because none of the dots are there. The best we could do is maybe something like from this empty one that actually is an illegal one, like 2 down and 1 across. That would be the proper slope, except that point doesn't exist. So there is no way. It's just the actual graph that we're looking at, which is just this part right here. There is no way to go 2 down and 2 across anywhere. So this initial slope right here, which we theoretically could have happened, doesn't actually exist for our particular puzzle. So let's focus on, how about the 2 across and 1 down? Or maybe it's, 1 across and 2 down. So does that ever work? Well, this one would have worked. Sorry, I said before this was a 2 across and 2 down. This is actually a 2 down and 1 across. So the 2-2 thing just never works. Just never wide enough here. So this one might have worked for the 2 down and 1 across, except at that point doesn't exist. So the only one that actually does work, so there are 2. This is a -1 plus 2. So that connection can be made there. And is that it? Yeah, I think... Oh, no, and this one here. So from here, this is a 2 down. Oh, no, that would be both being positive, right? You can't actually go connect here and here. There are no positive slopes on this, right? So there's always one positive thing and one negative thing. So this connection, though, does exist, right? There's a 2 down, 1 across, and that's a negative slope. So that works. And this one here connecting these two. So those will work as well. So those are the only 2 that involves that. Let's look at the 1-1 case. So that's just all the slopes of +1, -1. So that's just a bunch of diagonal lines going down. So there's that one there, there's that one there. I guess that's it actually. So that one there and that one there. And I'm actually going to draw these on in 1 second. I just want to look at this case, because this is the one weird case you have to be careful of. So this says if you got a 1-0, or equivalently -1-0, or because the type 1 and type 2 could be either pirates or admirals, it could also be 0-1-0, -1, that's basically saying you can go 1 step up, down, right, or left anywhere you want. So we can go across all we want here, we can go across all we want up here, we can go up and down here. You can't go up and down from here, there's no dot there. Remember, you can only go 1 unit. Theoretically, it seems like we could go up and down here. So definitely going across, there's no problems there. This up and down case was that thing I reminded us at the very start of this video, that saying it's impossible to go from a case with 2 pirates and 3 admirals to 2 pirates and 2 admirals. Okay, so we actually analyzed that case already and realized it's impossible. So even though the starting case is legal and the ending case is legal, you get into an illegal case for that split second with the boat doing it. So it turns out that is I'll let you think about it, but that's the only illegal possible scenario that we have here. So let's actually put in our lines at this stage. So our completed graph now looks like this. So this graph encapsulates the entire series of all possible moves you could ever do in the puzzle. So remember what our goal is. It's to start at this corner and get to any one of the red dots. So I should also point out these lines go both ways. So you can go from here to here, here to here. You can go any which way you want on it, because if you can get from one state to another legally, that means you can also get back again. You just kind of run the camera in reverse. So, all right. Well, now looking at this, I think it's pretty clear how you can go from the starting point to one of the red dots in the shortest possible way. So it's to go from this state to this one, here, here, here. And now you got a choice. You could either go to here or go to here. And that puts you at this one puts you in the state where there's 2 pirates left and no admirals. And then from there you would sail the last 2 pirates over. Or this would put you in the state where you've got 1 pirate and 1 admiral left, and they would both get on there and sail over. So that actually completes it. So this is every possible move you could ever make in that game. And one thing I like about this solution is it completely generalizes. So not only is it kind of nice that you can see the entire problem in one picture, but now we don't have to restrict it to just 3 admirals and 3 pirates. We could have, any number of admirals and any number of pirates. And the boat could hold a different number. We'd have to have more slopes if we did that, but you could even put a restriction and say, oh, it doesn't have to be that the pirates outnumber the admirals by any amount. You could say, well, it has to be that at least 3 more pirates than there are admirals, and that's when they beat up, or something like that. So, again, your graphs and your lines would look differently, but in the end, it would be the exact same process we went through, where you'd calculate the different slopes, calculate the legal states, and try to find a path going from one spot to another. So, for those of you that would like to actually see it in action, our solution, so I went ahead and copied our picture right here, and let's just go ahead and do the illustration with the pictures and see. So we're starting right here. And remember, these are the snapshots of the original bank with the rowboat. So we're starting with 3 pirates and 3 admirals. So it says that our first step, following our graph here, is to get to the state where we've got 2 pirates and 3 admirals on here. So basically you have to end up with 1 pirate over here and the boat back. So again, we can accomplish that in 2 different ways. We could send a pirate and admiral over and the admiral back, or we could send 2 pirates over. So yeah, let's go ahead and do that. So step 1, 2 pirates get into the boat. They sail to the other side, and notice that everything is still totally copacetic here. The pirates don't outnumber the admirals over here. There's no admirals over here. Everything's good. So, and then this 1 pirate is going to take the boat back. So now the boat's returned. We got 2 pirates and 3 admirals, so we're still perfectly good with the situation. And looking at our graph, so now we're at the stage where we've got 2 pirates and 3 admirals in the boat, so now we're at the second dot. So the next stage is to go to this third dot over here. So that third dot is 1 pirate and 3 admirals. So basically, the best way to do that is just to repeat the same process we just did. So that pirate will stay in the boat, this other pirate will climb in, and then the 2 pirates will sail over. So the 2 pirates have now sailed over, and then this 1 pirate is going to go ahead and sail back. So our snapshot now takes place again, so because we've got the boat back here, so we've got 1, 3, so that's this third dot. So it says our next step is to go to this dot. So this is the case with 2 pirates and 2 admirals. So, that means I have to make one of these admirals go over here and a pirate come over here. So what we're going to do is we're going to have, to accomplish this, so we need to have a net loss of 1 admiral and a net gain of 1 pirate. So to do this, we're going to send over 2 admirals and then come back with a pirate and an admiral. I'm guessing this is the step that most people that are just trying sort of things randomly probably miss, right? The fact that you're actually bringing back some pirates here and doing some exchanges. So far everything is fine, right? We got 3 admirals and 1 pirate here. We're going to send the 2 admirals over on the boat over to this side. So everything is still cool over here, right? We got 2 pirates and 2 admirals, so it's equal, that's fine. So, and now we're going to send back, so this admiral is going to stay, exchange with this pirate right here, and the pirate and the admiral will go back. So in this case now, the pirate and the admiral are in the boat, everything's still cool, they're going to sail back, everything is still going to stay equal once they get there. And now looking at so we were here, so we now need to travel to this dot right here. So this is the case where the next stage is we want 3 pirates on the side and no admirals, right? So what are we going to have to do? Well, we have to send all of these admirals over like this, send both admirals over, and then come back with the pirate. So let's go ahead and do that. So switch the place of the admiral and the pirate. These 2 admirals are now in the boat. Everything's still fine. They're going to sail over. So everything's cool over here. We got 3 admirals and 1 pirate, so nothing bad's going to happen. And now the pirate is just going to sail back. So these 2 admirals are going to stay, and the pirate's going to get in the boat. So the pirate's in the boat. He's going to sail back over to the other side, the original bank. Now, if you think about it, I mean, at this stage, it's pretty intuitive what to do. I mean, all the admirals are now safe over here, so all we have to do is, like, shuttle our pirates back. So I'm not going to bother to bring any admirals over. I mean, theoretically we could, right? But let's just jump right to this red dot where we just have 2 pirates left here. So the way to do that is have another pirate come on board to the boat. And then the boat sails off with the 2 pirates. When it gets to the other side, we're still perfectly okay because the admirals outnumber the pirates. And that same pirate can just sail back, grab the other pirate. So that pirate is now sailed back. We are now in the snapshot of 2 pirates and 0 admirals with the boat on this side. So we've hit our red dot, we've hit our goal. So now the only thing that's not captured in the graph is the final move, which is to load up everyone on this side and sail back. So pirate jumps into the boat, and the boat sails to the other side. And that's it. We went from here to this final stage, and everyone has now crossed the river, and no attacks.